G'day guys, Alan here. Welcome to my workshop. In this video I want to deal with a problem that's been bugging me for a while with some of my small clamps. The F style, which have got a sliding T-bar. In the smaller sizes, when you use them close together, the T-bars hit each other and get in the way. It's annoying. So I wanted to see if I could make things better. But things didn't go very smoothly. And I had quite a few goes before I managed to achieve something and get the sort of result that I was looking for. So perhaps join me and we'll see how it all turned out. I have a pair of these clamps which I bought about 40 years ago literally, and they're worn out. The ridges that are supposed to be on the spine here to stop this from slipping are worn off. It's sloppy everywhere, so sloppy in fact that the end comes off. But they have been really good clamps and I've really liked them, so I wanted to buy replacements, exact replacements. But the nearest I could get were these guys. Now these are pretty good clamps, they're forged and the spine would be stronger I dare say than that, and it has bowed a bit over the years. And the foot being forged in one piece doesn't suffer from this movement problem. That's good. It's got a really good foot on it for spreading the pressure, better than that one actually, so that's really good. And a good stop on the end to stop it from coming off. But what I don't like about them is the T-bar. You might suppose the T-bar would be better because it's an easier way of getting pressure on the clamping screw, and that's true. But I never had any problem getting the pressure I wanted just using the handle. And this actually has a big disadvantage because I often use these things in pairs, and when you do that, if they're close together, the T-bars get in the way. You can't tighten the clamps up properly, and that's a real nuisance. So I want to do something about that, and this is where all the time wasting started because I considered lots of different ways to do it and half did several of them. But just as a brief recap, I thought, okay, I'm going to want to be able to get hold of this, so I think what I'll need is a little V-block to get hold of it. Didn't have a V-block, so I needed to make it. And the bit of scrap steel I had was pretty rough, so I wanted to use fly cutter. That's the word I was looking for, a fly cutter. Now I do have a fly cutter. Unfortunately for me, it has a 3 Morse taper shank, and the machine I bought it for I no longer have. So I had to come up with some other way of driving it or make another one. Well, fortunately I have this thing, which is an NT40 to Morse taper 3 adapter. I use it for some of my taper shank drills, so that could work in the milling machine. But I realised that having it upside down like that, I needed the security of a draw bolt to make sure this couldn't fall out. And of course this thing also needs a draw bolt, and that's M16 and that's M12. And when I looked closely I realised I could actually bore through the bottom of this tapered or threaded hole using a boring bar and put an M12 hole, clearance hole, all the way through, which I did. And then I thought, okay, so now I can just make a drawbar up in the same pattern as the original that hangs on here. So I knocked this up. Remember, this is all time wasting, and that fits in the top of the spindle, the top of the quill, and I made up a high tensile rod. It's drilled and tapped for M12. High tensile bit of threaded rod goes on that end, and the other end happily goes in there, and will pass down through there. So it would work. But when I went to use it for the first time, I realised it was actually a pretty bad idea because it's not that easy to put it all together, and I didn't like it. So Mark II, more time wasting. I realised that I could machine an M12 socket head screw, cap screw down, so that just fitted through there, and then this will go down through there and engage in the top of that. So then it becomes a 2-part operation. Clamp that in there, then use the regular drawbar to hold that. So that's really good. I was happy with that, and it worked fine, and it allowed me to make my little V-block. So I'm making progress, I think. And then I realised, no, you've tried another snake, because what you were thinking about doing isn't going to work anyway. So when I cut the end off that and get that out, that's all fine. But I don't have any way, still don't have any way of holding this properly to put the hexagon on here. And I think really what a better option is going to be, it will be to get a joining nut and bore it out to be the right fit correctly around this thing, so that with that out the way, this board out to match that, then split. I can put the two halves one each side of that, and then I can hold it in the milling vise to put the hexagon on there and keep the indexing so I can get a good hexagon. So I don't know if you've ever heard of the song There's a Hole in My Bucket, Dear Liza. I'll put the words in the description below. That's what this feels like a little bit. So having gone through all that trouble, I'm going to do something completely different again, and hopefully get finally to a solution which will work. Just as another aside, by the way, this piece here was turned from this, and this is a piece of overhead line shafting which came out of an amateur's workshop, was put together in the 1920s. And he must have been a pretty gifted chap, because not only did he sort all that out, but he made his own pulleys, patterns, and cast them. And the little fella, he also made a cast and made up the plumber blocks to support the shafting, and the larger pulleys he made out of wood, and just as far as I could see, just cut them out by hand. A pretty clever fella. Anyway, by the by. Okay, so I ground the lump off one end of the Tommy bar and put an M6 thread on it, so I can put some sort of a threaded object on the air to trap it when we're all finished. Anyway, so now I can have that out, and the next move is to take a half-inch joining nut, half-inch UNC joining nut, and bore it out to match that diameter, which is 9.75mm, and then split it in two lengthwise, so I'll have two clamshells which I can use to clamp that in the milling vise. So I have one mounted ready to go. I'm going to drill it to 9mm and then bore it to 9.75. This boring operation won't clean those threads up completely, but I'm not worried about that. I don't think that'll interfere with the clamping function. And I've knocked up, because of those threads though, which will make it difficult to get an accurate reading with an internal hole gauge, I've made up on a bit of scrap a 9.75 diameter, which I can use to test fit. Let's just check the feed rate here. Yeah, that'll be alright. So let's set for 9.4 and see how we go. Should have made a shorter size gauge. Still not even looking at the hole. Yeah, okay, I think we've got a bit to come out. I think I might be getting more reliable readings on the diameter now, and that's 97 point. Sorry, 9 point. Well, actually that's suggesting we're right on it. I reckon we're going to be right on the money this time. Yep, I think that's going to be perfect. by the time I put my two slots to split this lengthwise, that should be just what we want. Okay, so I'm set up to split this nut into two halves now. This is just sitting there loosely at the moment. This is my size guide, but after I've cut this side and turned it around and put the clamp on again, this will support it while I cut the other side. The depth of cut I've got to make is 3 millimeters, but because I don't know how much I can rely on the clamping force here on this smaller vise, I'm going to take it in 1 millimeter deep slices and see how that works out. Because the last thing I want is for this to rip the piece of work out of the vise. I've got a bit of a splash guard set up here, so hopefully I won't get crap on the camera or whatever else, but we'll see how we go. So I'm just cutting at 100 RPM, so we'll see how that works out. Well, looks like that worked out pretty well, and without splashing coolant everywhere. Looks like I didn't need to bother with this shield I set up. Anyway, I'll turn it around and do the other side. So now I've got the slit on this side. When I do the vise up, it's clamping the nut tightly on this sizing guide, so it's still held securely. Fingers crossed. Now, this is close to breaking through here, so I'll just make sure this vise jaw is still tight. What's going on in there? Yeah, all still feels tight. I think if I get the old dentist mirror out again, I might just be able to see the back there. What do I have to see? Well, if that hasn't cut through, it's pretty damn close. So I don't think I have too much trouble separating them. Just make sure that my little hacksaw blade will fit in there. Doesn't look like it will. Oh yeah, there he goes. It does. Right. So if more cutting is required, I'll be able to do it with my little hacksaw. Okay, let's pull it apart and check it out. Right, well, my newly or nearly split nut is not in a hurry to separate from the supporting shaft, so it's going to have to be persuaded and go up a size in the punch, I think. There we go. It'll go straight through on the floor, I imagine. There we go. Doesn't look like I cut right the way through anywhere. Okay. Well, I'm not sure how well you'll be able to see that, but maybe you can see that it's very close to having come through. I don't think it's going to take much to separate it. So I think what we'll do is put him in here like this. and run my little saw through it. And I don't think it's going to take very much. No, there's one. There we go. I think it works out alright. Well, a bit of a clean up of the file, and we'll see if it worked. This is where all those bloody little steel splinters jump up and down and say, "Pick me! Pick me!" Just trying to make it safe to handle, that's all. Okay, so I'm getting ready to machine the hex pattern on this head of this screw here. And it's a bit of a MacGyver setup, as the Americans might say, or being English by birth. Heath Robinson, as I might have said, as a young bloke, before I became Australian. Anyway, so what's going on? There's the split nut holding the thing. This machinist clamp is holding those two halves together only so that when I take it out, let the vise off, I don't lose the grip these things have on that, because this is clocked, of course. Not just so I get a hexagon pattern, but so that hopefully this hole here will be in the middle of a flat side. That's the desired outcome. Anyway, so that's from this side, and the two blocks, you'll see the purpose for these two blocks when we look from the other side. And of course I've got to stop to just give me something to position it to. Mostly because I don't want to obviously drift too close here. I don't have a lot of room to play with just there. So looking at the clamping setup from this side, this is just hanging loose and it's just being held up by this bit of scrap. And it's the fact that you can't get the screw out that makes this also difficult. But this split nut is being supported here by the other half of that V block, which I made up and I thought was going to be useless, but in fact is already doing useful work. And obviously the clamping force from the jaws of the vise is transferred through these blocks to that. And looking at it and talking about it with you, I've just noticed something which is very important. I don't have anything at this end of the vise to balance out the clamping pressure at this end, so that it's forcing this to be cocked. So I must fix that up and put a block in there, just as well I had a look. Right, you'll be able to see the jacking screw down there, which should keep the vise jaws parallel and improve the chances of this staying where I want it to be. So I'm wanting to convert this to 7/16 across the flats. It's starting out at 12.8 diameter, so I've got to get down to 11.112. Basically I'm taking about 0.84 off each of the 6 faces, of what will be the 6 faces. I'm not liking the way that's going. I'm wondering if the thing's turning. Let's lift this up and have a look. Just slip this back in there and see if it still looks horizontal. I reckon that's rotated in the clamp. That's what I think's happened. Alright, better stop here and have a good check and to think. Well, I've had a good look and I don't actually know whether it started to rotate or it didn't. It possibly didn't. I've just this drill is a fairly close fit to the hole, and viewed from that perspective it still looks like it's horizontal. So I think I might continue, but just do it in two, because this is looking like this is quite tough stuff. I might do it in 2 passes. Instead of doing the whole 0.8, I might go at 0.4. Okay, well, let's see how that goes. Cutting at 0.4 now instead of 0.8. No, that seems to be alright. Let's go for the 0.8. I didn't like Didn't like the change in that note, the machining note. Yeah, that's definitely rotated it. Not much, but it has. So, what to do? Bring it back and take even smaller swipes, I suppose. Okay, well, after a lot of patient fine cuts, I got a result. The thing had turned a little bit in the chuck, in the vise, but I think the main problem was I'd just been a bit too cautious with how tight to do the vise jaw. Didn't really want to mark those 1, 2, 3 blocks. But I sort of figured, well, hang on a second, they're there to do a job and they've got to take their lumps. So I gave it some A-bomb type torque and didn't have any more slipping. So I did get left with the dig-in mark here and also this unwanted flat, because as the astute of you would have noticed back with my earlier picture and setup, I had it clocked incorrectly. But it doesn't seem to have caused an enduring problem. The 7/16 socket still fits on there very nicely, and we'll get the job done. So not ideal to have that muck up, but hey, the thing's still going to be useful. Now I've dealt with the Tommy bar, tightening bar, so I ground off the one lump, threaded it with M6, and I've made up this little replacement knob. So the thing will be able to be used now in either configuration. But of course it definitely looks better from that side. Right, so I've got a bit of a laundry list of pieces that got made along the way, and were stepping stones. Well, that goes in the drawer, might or might not ever be used for anything, who knows. These things, well, they may or may not get used again. And my little V block cut into 2. Yes, I think that'll be useful for something. And this is a part going forwards for when I want to use the what is that thing called? I don't know why I couldn't remember that. Getting old and senile. Anyway, so for when I want to use the fly cutter, that'll be the way I hold it into that int 40 holder. So overall, I'd call the project a success. I don't think that I'm going to modify this other one in the same way, because obviously I can put this one on first and then put this one on with the handle removed if necessary. But what I might do is doctor this handle in the same way I did that, so at least I can remove this handle if it's getting in the way. But I'm calling that project done, and hopefully you found something interesting in all of that and enjoyed it, and in any case, hope to see you on the next one.